Okay, and this is the part that took us a really long time to understand this morning. So hopefully we can go through it relatively quickly. For the first case, we're just going to pick x equals 2. And we're going to look at this polynomial here, x squared plus x plus 1. And what does that evaluate at when x equals 2?
Well, it's 4 plus 2 plus 1, so that equals 7.
That equals 7. So we're going to start with 7. Okay. Now, to go to the next case, we take advantage of this factoring trick. And we're going to let x be 2 to the 2 to the n minus 1, where this is n over here. Okay? So now we're going to go to x equals 2 to the 2 to the 0. And what is 2 to the 0?
1.
Okay, and then, so what does x equal here?
X equals 2.
X equals 2 again. But now we're going to look at the whole polynomial. It equals, what does this evaluate out to when x equals 2?
16 plus 4 plus 1.
16 plus 4 plus 1.
That's 21.
21. Which happens to equal 3 times 7. And notice that 7 up here comes from here. See how this factors? This was 7 when x is 2, and this is 3 when x equals 2. 4 minus 2 plus 1 is 3. Alright? Now let's go to the next step. X equals 2. So we say x is 2 to the 2 to the 1.
So that's 2 to the, that's 2 squared, which is 4.
Which is 4. And what does this evaluate out at when x equals 4?
So this is 4 to the 4th is 256.
Okay, 256.
Plus 16 plus 1. So it's 273.
273, which happens to equal, evaluate this at 4.
It's 16 minus 4 plus 1.
So what is that?
That's 13.
13 times.
And this one is 16 plus 4 plus 1, 21.
20. So that's the number we had up here. So we found a very clever way, and I'll explain that in a minute, how to walk up the ladder by just picking. For 3, we would have x equals 2 to the 2 to the 2. For 4, we would have x equals 2 to the 2 to the 3.
And these get big fast.
They get big really fast.
Like, I think that the 7th one was like the 100-digit number or something.
Yeah, yeah. So the amazing thing is by this factoring process, actually let's do one more, because we can't understand this. This is 2 to the 4th, right? 2 squared is 4, so this is 2 to the 4th. But we know 2 to the 4th is?
It's 16.
16. 16 squared is 256.
Yep.
Minus 16 is 250.
So it's 250. Wait, no, it's 241.
240, sorry. 241 times, and hopefully we're going to get 273 here. 256 plus 16.
That's 272 plus 1 is 200. It's 273.
273. So we bootstrap up here. Okay. Now what we said previously is these have no common factors. 3 and 7 have no common factors. 13 and 21 have no common factors. 241 and 273, which is 13 times 7 times 3, we know they have no common factors. So this is 1 prime, 2 prime, 3 prime, 4 prime. Turns out 241 is prime. Much like the Euclid proof, it doesn't have to be prime. It just doesn't have, it has to have no common factors with this. Okay. So we seem to keep arriving back at one of the factors. We come up with a number where one of the factors is the previous term. So the only thing to understand is why is that happening? Okay, so that's the clever observation with this polynomial. Let's do one last movie and show why that's true. Okay?
All right.